we start?
Sure. We can do that. So this is we're recording. So this is our warm-up. Our warm-up was complete the square sum method, so it squares each number passed into it and then sums the results together. For example, if you get square sum of 1, 2, and 2, you should return 9 because 1 squared plus 2 squared plus 2 squared is 9. 1 squared is 1, 2 squared is 4, so 1 plus 4 gives us 9. So this can be done a lot of different ways. And it kind of depends on how you see the problem being broken down. So let's do it kind of the long way, and we'll kind of progress to the shortest way. So maybe you decided that there was going to be a sum variable, that you were going to keep track of this sum. And then maybe if we go through each of the numbers, and every time we get a number, maybe we take the sum and we add to sum the number times the number. So we're starting with the sum being 0, and we're going through each of the numbers one at a time. That's what for each does. And for every one of those numbers, we're adding whatever that number is times itself to sum. And in the end, we return sum. So if you thought to yourself, well, the way you do this is you keep a sum and you look at the first number, that's 1. 1 times 1 is 1, add that to sum. The next number is 2, 2 times 2 is 4, add that to sum, I have 5. Right? Maybe your process that you came up with, the instructions that you wrote, flowed like that. And if you did, you'd probably come up with something like this. So to shorten the syntax a little bit, we can use the plus equals. That's a little bit of a shortcut. And if you did a little bit of Googling, you may have found that there's another operator kind of like star, which is the exponent operator, 2 stars. So this means number squared. Number times 2 is number squared. So maybe you had this, right? Or maybe when you looked at this, you said, oh, look, I have a little array here, 3 elements, and I kind of have another array here. These numbers, right? 3 numbers go in, 3 numbers come out. Maybe what you did, I'm going to leave this one here. Maybe what you did is you said, if I go through all the numbers, and I instead of for each, I map them, and I return, for every number, I just return its square. So this will make me a new variable called squared numbers. Maybe you kept your sum, and you said, well, I'm just going to add up, not the numbers, but I will add up the squared numbers. Can I comment that? Yeah, let me comment this out. Oops. Oh, I'm missing an equal sign. Okay. So maybe you decided, when I looked at this, I see a list of numbers being turned into a different list of numbers, and then I'm adding those together. Right? Maybe if that was your instructions, first turn my list of numbers into a list of squared numbers, and then add them up. And maybe instead of using a for each, you want it to be uber cool and use reduce. That looks like this. And then maybe you realize, well, if I just make the sum variable and return it, I can just return the result of reduce. But then if I also look at this, I can apply a couple of our rules. We have an arrow function that just says return one thing. So that means I can get rid of these parentheses, and I can get rid of the return keyword. And I can get rid of these, braces, and get rid of this return keyword. And that still works. And I can tidy this up so it's all in one line, because that's typically how we write these. We can look at this. Then we can apply another rule, which is if we create a variable and we only use it one time, take whatever that thing is and put it where the variable is and get rid of the variable. And you end up with something like this. Maybe we put these on separate lines so we can read them. So the way you would read this is, say, squared sum is if you take the numbers and you turn them into another array where each number is squared, and then you sum that, and you remember to put the initializing 0 there, you sum those up. So that's progressively using more advanced techniques. This one here is probably the most direct from the instructions. Just going through, making your sum 0, go through each number, add that number to the sum, and then return whatever that sum is. And then each of these is progressively using more advanced JavaScript features. And most of you come up with something like this, those of you who finished it. It's some combination of this.
I was trying to do the first one, but I'm still like getting the wrong.
This one here?
Yes.
Yeah.
But I changed function to constant and then made it look normal.
Made it an arrow function?
Yeah.
Yeah. That's fine. You can leave the function this way. That's fine. Cohort is not going to assume that we're working with new style arrow functions, so they're going to write the function word. You don't have to change that if you don't want to.
I'm still getting the wrong answer, though. I don't know why.
Why don't you paste your code into Slack, and then we'll take a look at it. Anybody else do it a different way out of any of these? Sometimes with a room of 8 people, we get 8 different types of solutions.
I stole the times 2 because I was doing it like the longer way.
So let's take a look at it. So anybody see what Shay's challenge is? When you know it, don't say it, raise your hand. When you think you know what Shay's bug is, including Shay. When you know it, just raise your hand. Yeah. Do you think you see it? Shay, if you think you see it, why don't you say what you think it is? We'll see if we got it. So those who raise your hand, just say what line number you think the bug is on. Yeah. So the bug is, now no one say what it is. So those of you who weren't sure what it is, take a look at line 5 and see if you can figure out what the bug is. It's not this. I'm just doing that for clarity. So think about what the code is supposed to do, and think about what the code is actually saying. If you then think you see it, now you can raise your hand. So somebody who isn't have their hand raised, why don't you read to me, somebody volunteer, read to me what line 5 does. Kind of translate that into English. This is good practice on debugging. So somebody who didn't have their hand raised, who thinks they know what it is, somebody volunteer. Michelle? Michelle's volunteering. So why don't you read to me what you think line 5 does in English?
Well, I'm not.
Oh, you were not volunteering?
No, I
Okay.
I kind of have a question. Does he need the 2 there?
He does.
Okay.
Yep. So he could write it like this, or he could write it like this. Either of those are fine. That's not the bug. So somebody want to take an attempt at saying in English what line 5 does?
Line 5 is declaring that number. It's declaring that sum is equal to number times number.
Yes. And Frank, what should it do to sum? Right. Let's work through it. Let's work through it one at a time. So if we have numbers being 1, 2, and 2, the first time through this loop, what is number? If numbers are this, let's make it a 1, 2, and 3. If this is our array, the first time in this for each loop, what is number going to be equal to? 1. So what is 1 times 1? And what is sum going to be? 1. Right? Sum equals number squared. So sum is going to be equal to 1. The second time through the loop, what is number? 2. What is sum still? Right? It's still 1. So what is number squared? 4. And what are you going to do to sum? It's going to make it 4. What did we mean to do to sum? We meant to increment it. So what Shay is missing is this. It's not adding anything. He's replacing sum each time. Right? He's not incrementing sum. He's just saying whatever sum was, get rid of it, and sum is now this. What we mean to do is either plus equals it or sum plus it. Right? This is why reading the code out loud, or what Michelle and I were doing yesterday, is come to the whiteboard and kind of pretend to be JavaScript. Right? Pretend to be that like Python code viewer where you step through the code one at a time, and even if you have to, trust me, as a programmer who's been doing this for 15 years, I still do stuff like, I don't know why this code's not working. I write sum is 0. Numbers is 1, 2, and 3. And I go through the code line at a time and say, okay, well, number is this guy. Well, 1 times 1 is 1, and sum equals 1. Then move on to 2. 2 times 2 is 4. Sum equals, oh shoot, I don't want this to be a 4 now, I mean that to be a 5. And you'll find the bug. So it often means you have to role play the JavaScript language itself and go through each line of your code one step at a time, trying to see what your code does. And these kinds of things will more pop out to you. Oh, Shay, did that fix what you were looking for?
Yeah.
Okay.
How does so we let sum equal 0, like that one, and then we run the function that redefines sum. How does return know to pull it from the function?
Because it's not pulling it from the function. All we're doing, what the function is doing, is changing the value of sum. So sum exists as a variable, and every time through this loop, all we're doing is we're changing that variable.
Well, how does that happen?
So the function doesn't know anything. So if you think about what's in JavaScript's memory, so imagine JavaScript being a thing that has all these buckets, right? And buckets represent variables. So we have a bucket called numbers, and that has 1, 2, and 3 in it. Then we have a bucket called sum, and that has a 0 in it. And then as we go through this loop, we make a new bucket called number that one at a time plucks a value out of our numbers bucket and makes that the variable, right? So here's our numbers bucket, and number becomes 1. So now if we ask JavaScript, what's in your memory? It would say, cool, I've got a thing called numbers, it's got 1, 2, and 3 in it. I've got a thing called sum, it's got a 0 in it. And I've got a thing called number, and it's got a 1 in it. Cool. Then we tell JavaScript, go take the thing that's in sum, it's a 0, and add to it the thing that's in number squared. Well, that's 0 plus 1 times 1, that's 1. and we tell JavaScript, whatever that is, go stick it back in the bucket called sum. So now if you ask JavaScript, what's your memory look like? It would say, I've got a thing called numbers that has a 1, 2, and a 3 in it. I've got this thing called sum that has a 1 in it. And I've got this number that's a 1. Go through the loop a second time. Now JavaScript says, I've got a thing called numbers. It's got a 1, a 2, and a 3 in it. I've got a sum variable. It's got a 1 in it. And I've got a number variable. It's got a 2 in it. What does it do? It takes sum, which is 1, and adds 2 times 2. So, right, that's 1 plus 4, that's 5, and puts 5 back in the thing called sum. Now JavaScript's like, cool, I got numbers, which is a 1, a 2, and a 3, got a sum that's a 5, loop back around, now number is 3. So JavaScript has to say, go to the bucket called sum, which has a 5, and add 3 times 3, right? 9. Now that's 14. I stick a 14 back in, did I do that right? Yeah, stick a 14 back in sum. So now JavaScript's like, hey, I've got this bucket called numbers. It's got a 1, 2, and a 3. I've got this bucket called sum. It's got a 14 in it. And I've got a number that's a 3. Ah, this loop is done. Return what's in the sum bucket. What's in the sum bucket is a 14, right?
So when we return, we're returning
The value of whatever's currently in sum
to the main function.
to whatever called me.
Okay.
Whatever called me gets this back. Every function has goes intos and a result. So whoever called me is waiting for this result. And I'm going to return to them whatever that result is.
So functions within a function, because it's kind of what we have here,
Mm-hmm.
can redefine things that we just have defined.
Anything can define anything that's already defined. It doesn't have to be a function. If I said here, sum equals 99, I'm redefining what's in sum. You can redefine a variable anytime you like.
So at that point, would it return 99? Or would
Absolutely, return 99.
Because it's the lowest thing on the...
Because it's the last thing it did before it got to the return.
Okay.
JavaScript's moving through our code line by line, doing whatever we tell it to do. If at the very end we throw away all the hard work of summing that variable, that's what you told it to do.
So if we were to define sum 0 below the function, what would happen?
If you defined a sum here,
below, right above return.
this,
Would that change?
it won't let you do it because you can't let it again. You can't let a variable twice.
Well, if you didn't put it.
If we didn't put it up top and we put it up above.
You put this here,
Yes.
well, this would break because you're trying to use a variable before you've
Okay.
defined it.
That's what I'm trying to figure out.
Yeah. So first you define a variable, then you use it, then you could possibly return it. You have to define the variable or initialize the variable before you can use it.
So if you took out that let sum equals 0, it won't assume in that function that sum is 42?
Nope.
No, I'm saying if you put sum
I would
equals 42 below.
I would still get an error
Oh,
because when this gets here the first time, it can't look ahead in your code and see what else is going on in the function. The code inside of a block executes line by line by line by line by line. Right? So it can't see this let sum equals 42 because I haven't gotten there yet. It's just working its way line by line by line and then loop and then looping and then looping and then looping. Right? But when it gets to the sum, it's like, what? How do I know what sum is? Now, if I had put let sum equal to 99 up here, now I got a problem. Because this sum can see this sum outside the function. Right? Anything declared outside of a function at a level higher than the function, this can see.
Not below the function?
It doesn't matter as long as it was declared outside of the function before the function is run. Now we're getting into weird JavaScript rules. This is why I generally don't want us to be declaring variables out here, because it makes a mess. We're mixing chocolate and peanut butter, which is delicious, but in programming we don't want to do that. Which is why, like, on the first couple of days before I have taught you anything about rules and we have dealer hand and those things, I declare them outside, because understanding JavaScript scoping rules is really hard. But this essentially says this variable sum is available to everybody. Everybody can use sum. you get a sum, and you get a sum. Inside of here, we're saying this sum variable is only seen by the square sum function.
So if you have, and I'm sorry, you may have already answered this and I missed it, but if you have let sum equals 0 there, just how it is,
Mm-hmm.
but then like you're doing something else in the code somewhere completely different, and you have let sum equal 50
Mhm.
outside of the code, is it gonna stick
Those are
with the-
two different sums.
So it's gonna recognize the 0 first.
It's only going to recognize a 0 when it's inside of here. So imagine if every variable had before it the name of the function that it's in, kind of prefixed to it. This sum here, if I have another function, zippy, let sum equal to 99, console.log sum. This sum and this sum have absolutely nothing to do with each other, other than the fact that the variable names are sum, because they're inside of different functions
What if
that
you
don't
didn't
touch
have-
each other.
What if you didn't have it inside the function? It was just
Then they all, yeah. So if this is on its own, now it's a different rule. Now these two things are kind of inside each other. They're inside the same file. And now this sum and this sum are not the same, but if I take this let out, now they are. This sum and this sum are the same sum. Confusing, right? So here's my rule. We would get 99. We would get something more than 99, more than what we were looking for, right? If we did this, the first one passes, but the second one fails. Why?
Because the loop can't go. Wait, is that right? The loop can't go back out of the function.
No. Think about where sum is. Sum is global. So every time we call square sum, we're never resetting what sum is. Right? Sum exists outside of the function. So the function's kind of borrowing that variable. The function's saying, well, I don't have a let sum. Oh, but my parent did. I have access to that scope. I'll just reuse that variable. And the second time we call square sum, we don't clear out the value from before, right? This is why having variables declared outside of a function that you use inside of a function is so dangerous. Because now multiple people can have their fingers in that pie, right? Can access that variable. Right? This is why, like, for the first week or two of JavaScript, we do this, because teaching you how to like pass variables around and having global variables is challenging. Which is why, like, when we jump now next week into React, we're going to stop doing variables like this outside. Like, let player hand equals to array outside of all of the functions. Because in practice, it's a bad thing to do. It leads to weird bugs that if you forgot to do this, you'd get bugs. So this is why we tend to try and keep variables scoped as wherever we need them, we put them inside of that function, like so. This is also for the var people, right? Why we avoid var.
I'm not sure.
Because var is file scoped, not function scoped, for the var people.
So if you had let sum equal 52 completely above this, and everything else stayed the same,
These are two different sums now.
I know they are. So would this would still work?
Mm-hmm.
It wouldn't even see the 52.
Correct.
Right? Okay.
Because this sum says, I know if the word let says, I don't care what other variable you have sum, I'm telling you that I want a variable called sum, what I want it to be. And it says, okay, cool, you had a sum outside, but I'm gonna ignore that sum and do this one. Which is why we don't just do this for variables. Because this is perfectly fine JavaScript. This is perfectly fine JavaScript. Right? We don't do it because this sum could be this variable up here. Right? And if we had another function, zippy, right? Now we've mixed, all these sums are kind of mixed together. The one that's outside of the function and the one that's inside of the function. Which sum are we talking about where? So this is why this let keyword is so important and why we tend not to do this, making variables outside of any function.
So you kind of define sum equals 0 whenever it was like just sum equals 0 without the let. What does that do? How's the
It's
scope
not
of that?
it's not defining it, it's just resetting whatever some variable happens to find lying around.
Well, you would also, whenever you did sum equals 0, you would gotten rid of your let sum equals 52.
Right.
So there was no let for sum.
Right. So if we go back to, you're talking about going back to here.
Yes.
Right. So what this says to JavaScript is like, hey JavaScript, go look around and see if you got a sum variable hanging out from your parent, from the scope of the whole file. Anywhere in the file, in the global level, did somebody declare a sum? No? Okay, cool. I'm going to do it right now. I'm going to make that sum variable 0. And this sum variable is now leaky. Other functions can use it because we've let it leak the scope. We've said this sum variable is just willy-nilly. Anybody can use it, whatever. Everybody's got a sum, right? Sum, you get a sum, you get a sum, everybody gets a sum.
So that's the same as var. Sum.
This is the same as var sum.
Okay.
And why var is so dangerous. Powerful, but also dangerous. So this is why from the first day I've been having you all do let sum equal, let sum equal, let sum equal. Because you don't actually need the word let. What let says is, I don't care what other sum variables you might have had outside of this function that might leak inside this function. I'm telling you, I'm making a variable called sum, and the only place that this version of sum is useful is inside of this function, right? What's even more mind-blowing is if we say something like sum equals 52, right? And we call square sum of 1, 2, 3. Let's console.log sum. Let's call square sum. Let's console log sum again. Let's console.log this, right? So we made a sum variable and made it be 52 up here. Then we're using this sum variable inside of here. 52, 14, our sum variable here is still 52. This sum did not affect it. This sum variable and this sum variable are two different variables. But what if I leave the let keyword off of it? 52, 14, 14. Now it did touch this variable up here, right? Boy, it gets weird when you stop putting lets on things, doesn't it? Right? And you can imagine a program that's tens of thousands of lines long, and you just start using variable names. Well, how do you know that someone else 15 functions away didn't also use that variable name and did something else with it and reset it on you? You have no way of knowing. So this is why, generally, we let all of our variables to claim them as ours, and why we tend not to allow ourselves to put variables up outside of all functions. Cool, that's a good discussion. It's a little bit like inside baseball, like the reasons behind some of the rules that I've been placing on you, because you don't tend to feel those effects until you're working on a much larger code base, right? Hundreds of lines long or thousands of lines long, or code base that has like 600 different files in it, all doing something, and you've declared a variable now that somebody else is leaking into. But it's an interesting thing. Cool. Let's, any other questions on the kata? Cool. Let's go and talk about our Star Wars thing we did yesterday. So here's our Star Wars code just to refamiliarize ourselves. Because we're going to work with this today. We're going to do a brief introduction to React. But here's a bonus for you. Your homework for this weekend is not a React homework. Your homework will be kind of your last plain JavaScript web page homework before we layer in React. If you want to attempt to do the weekend homework in React, you're more than welcome to. But unless you're itching to push yourself a little bit, I would say not. Normally, this is the lecture we would do on Monday, but since we don't have a Monday, we're going to do like an introduction today, and then we'll do a mini review Tuesday, and then continue with our React work. So here's our HTML for our app, right? It's got two headers, Star Wars and characters, and this blank UL. And then we have this JavaScript that fetches some data from the Star Wars API and makes sure that it's JSON. And when the data comes back, it gets back this raw data, right? This raw data that looks like that looks like this, right? It's got a count and a next, and it's got these results, right, that have an array of objects, so on and so forth and so on. And yesterday what we did was we took this raw data and we turned them into character classes to represent the data. And then we went through all of those characters and we built we built LIs with that character's description and appended them. Right. And we talked about the fact that if we change this page number, we get different characters. Let's build in the pagination that we didn't have before. So let's make it so that we have underneath here, we have a button let's just add the button. So we've got a button now that what I want to have happen is when I click this button, I would like for this to move on to the second page of characters and tell me which page number I'm on. So let's add in an H3 that says we're on page 1. What's that going to look like? Let's also center that. Cool. So when we now click on this button, for next, we want this to go page 2, page 3, page 4. So what I said we don't do, right, is have this page number be 1 just kind of floating out in space. We're going to see when we start looking at React why we're not going to do this anymore and what React gives us to avoid having these global variables floating around. So let's make this page number 1. And then let's make this a dynamic string. Right? So now, if I change this number, right, I'm on page 2, and I'm on page 3. So now my little URL here is changing, it's reacting to the change in this variable. As I change this variable, this page changes. So let's put this back to 1. So now in our main, let's say we query selector for that button, and then we add an event listener on click to call a function next page, which we haven't written yet. Right, this function we haven't written yet. Let's do it this way. Put it on separate lines so we can see. Oh, and yay, it's going to move this back up. So now we need to add this next page function. And all this has to do is increment the page. Except it's not doing anything yet.
Maybe change the text too.
Yeah. Yeah, let's change the text too. So let's go find that H3. Let's make its text content be equal to the current page. Oh, actually it says page and the current page. Right, but nothing's happening because I'm not calling the function to go do the API, right? So let's separate out this into two parts. So this is the part that does the fetching, right? And this is the part that does the rendering. So I'm going to make a function called render. I'm using that name very specifically because we're going to see why in a minute when we start talking about React. So let's make a render function, and let's have it take in the raw data. It's going to accept the raw data from the API, and we're going to move all this work up here. So now we have a little function we can call that when we get raw data, we can call render and pass it the raw data. So all I've done is I've moved the function, all the code that did the rendering, did the parsing of the raw data and the rendering, into a little render function. So now that means that every time I change the page, right, I can just call this function. I can duplicate this code. Right? Let's change the page and fetch the data. Uh-oh. Well, what's happening? Yeah, it's appending it all. So let's fix that. Let's pull this UL, put it up here at the top of the render, and then every time we render, let's set the inner HTML of that to blank. So every time we render, we're zapping what's inside the UL and replacing its values. Except, do you see something that's a little weird here? Yeah, it lags because we're changing the next page selector, and then we're fetching the API, and then later on it's rendering. So let's move this. Oops. Undo. Let's leave this here. Let's move the suggestion of changing the page to be inside of the render function. So now we're going to increment the page and do the fetch, but we're going to update the page number and the contents all at once. All right, and now there's a little lag while it's fetching, but it's okay. Maybe what we want to do here is do something like, let's clear out the UL. Text content is loading. UL append child, new li. So we'll make a little loading bit. Right? We would fix the formatting of that, but now we've got a little like progress thing, right? And we're going through the pages. Right? Going the previous page would be the same thing. We would just minus equals 1 instead of plus equals 1. So you see, we've had to do some work here. We've had to be responsible for clearing the UL, and we've been having to be responsible for building up all these LIs, right? But what's really happening here? If we think about this interface, as we look at it, these LIs here represent whatever data we got back from the interface. And this number 7 here represents whatever's sitting in the page variable. Right? As soon as we change the page variable, we want that 7 to be the 7 that's coming from the page variable. Wouldn't it be cool if we could just change that page variable and the interface would update on its own? We'd have to teach it how to do that. Or wouldn't it be cool if we were able to change the data for the list of characters and the interface would just update itself on its own? Right? This is the idea of how the React framework or library works. The idea that your user interface is itself data and behavior. Right, we've been saying this time code is data and behavior, data and behavior. What's the data on this page?
Descriptions.
Yeah, descriptions of characters that come back from the API, and yes, but more specifically, the page number. Right? Yeah, it's the page number, it's the description, and it's the count of films that Kenny said. What's the behavior on this page? What can the page do?
Switch lists.
Yeah, you can go to the next page. Yeah, exactly. Right? Every time I click the next button, I want to go to the next page of information. So React kind of captures this idea of data and behavior in that the user interface will react to events, and it will also react to changing data. That as we change data, the user interface changes automatically. And a lot of this kind of boilerplate work that we're doing here, things like, hey, go find the UL and clear it out because I'm going to append some stuff to it, whoosh, just goes away. Right? We've kind of shown you the nitty-gritty, low-level, detailed way of building these things, and now we're going to do some hand-wavy stuff and make it all go away. Right? But every time we do that, right, we add some complications. We don't get anything for free in programming. Right? We're going to gain all of this ability to say, hey, every time I change the page variable, I want you to change what's in that page number. And every time I change what's inside of this data, I want you to refresh the page. Right? In order to get that power, we've got to kind of live within the constraints of the React library. We have to adhere to its rules. Right? We have to do things the React way so that we get that ability. So let's take a quick tour through React. Here's what we're going to do. I'm going to save this work and commit it. So we're going to take a quick tour through React. I'm going to show you some of the features of it. And then what I'm going to do is I'm going to come back to Star Wars. I'm going to recreate Star Wars now as a React application. Right. You're welcome to take notes and try and follow along. Just know that there's no homework tonight on React because we're going to go over this again on Tuesday morning. So this is like a sneak preview. Right. Your homework for tonight is going to still be using this style, right? The style we've been doing. And then it's up to you if you want to push yourself over the long weekend to I'm going to try and do it the React way without having the full, slower, detailed lecture on it. So if we go to React's homepage, I'm going to get out of full screen mode here. If you go to React's homepage, right, React says it is a JavaScript library for building user interfaces. That's kind of what we've been doing. That's what we've been using JavaScript for, right? We've been using it to build user interfaces, right? A user interface for playing blackjack, or a user interface for playing rock, paper, scissors. Cool. So React says it's declarative, it's component-based, and it's learn one, write anywhere. Let's talk about the first two, and maybe we'll touch on the third one a little bit later. So let's talk first about the middle one, that it's component-based. Build encapsulated components. Oh, there's that word encapsulated again. Encapsulated components that manage their own state, data, and compose them to make complex user interfaces. Since component logic, behavior, is written in JavaScript instead of templates, you can pass rich data to your application and keep state out of the DOM. So you can think here that components are like classes, because that's how we're going to implement components. So React is a class-based thing. Now you don't have to use classes with React, but it's a common way of creating these components that we're going to make them classes. Right? So React is very heavily class-based. Right? And they manage their own state. Well, state's just another word for data. If you remember the other day, we had our little hand class, right? And hand had an array of cards. That array of cards is that component, that class's state. You would say the the hand component has a state of cards. So when we talk about state, we're talking about data that's owned by a class. So I was just kind of saying here that you're going to see a lot of classes, and we're going to see a lot of classes owning data. Declarative. This is, I think, kind of the cooler part. React makes it painless to create interactive user interfaces. Well, that's mostly what we've been doing this last couple weeks, right? In the first week, we made non-interactive UIs, right? We made octocats, and you could like, drag the window around and see the octocats change, but you couldn't add more octocats or take octocats away or change the name of an octocat. Right? It was a non-interactive user interface. Then we added JavaScript, right? And boom, we could make a rock paper scissors game where things are clicking and the interface is changing. This is what React is trying to make more painless. We'll see if it's entirely painless. That's their claim. So we design simple views for each state in your application. So what this is saying is we're going to define some HTML that's going to be matched up with data. So React's going to give us some way of taking our HTML and our data and smoosh them together so that that ends up in some display of information. React will efficiently update and render just the right components when your data changes. So when that page number variable changes, React is going to go into our user interface and find the place where that page was used and just change it. It's going to find where that list of Star Wars characters were and paint them. We're not going to have to tell it how to go in and delete all that data and put it back in the interface. We declare to React, this is the way I want my interface to look. My user interface, this is where my ULs and LIs go, and this is the data that they use. And when that data changes, React's like, cool, that data changed. I'm going to go change the user interface to reflect what the data is. Right? For those of you who are picking up the idea of the JavaScript map, this is what I like about React. It's like your data is in one place, and you run it through a map, and out the other end comes HTML. Right? It's transforming your data into HTML. If we just teach React how to take our data and turn it into HTML, every time the data changes, the HTML changes automatically. And we're no longer in the business of writing, go find the UL, document query selector, go build an LI, set the text content, append it to the right place. That all whoosh goes away. We say, hey, I've got a UL that has as many LIs as there are characters, and this is how I want them displayed. And then React's like, cool, I can do that. And we're like, hey, React, here's my list of characters. I got you. Boom, it draws the list of characters. So let's see a little bit of how that works. So if we scroll down here, and you can follow along, this is just reactjs.org. You can play around with this too. Here's a simple component. So we see some familiar things, right? Class, a function, a return, but there's some new things here. The first new thing we see is extends React component. All right, this is a syntax we did not see yet with classes. So the extends keyword here means is a kind of, has all the abilities of. You can think of extends as any of those. It is a, right, is a kind of, or has all the abilities of. So we're saying that a hello message component class has all the abilities of a React component. So when we start working with libraries, we're going to be importing this code into our projects, and then we can make our code work with that code. So that first line just says, our hello message is going to be a thing called a React component. Right? And then inside of that, we just have a render method. It's kind of why I call the render method of my Star Wars API render. Because every single React component is going to have a render method. And that render method tells that component what to look like. The rule for that render component is that it must return some HTML. Doesn't that sound weird? How does a JavaScript thing return HTML? We've never like stuck HTML right in the middle of our JavaScript. But React lets us do that. Notice, what does it return? Let me get my cursor out of the way. It returns a div. What? We can write HTML right inside of this return statement. React is expecting us to return HTML. Right? It's expecting us to return one HTML element. But that HTML element can have other elements inside of it. But the rule is every React render will return one parent DOM element, a div, a UL, a p tag, that could have other child elements in it, but just one parent. And then inside of that, we have some content, hello, and some garbage there. We're going to skip over what that garbage is for a moment and come back to it, right? Hello something. Then at the bottom, I want you to just to look at this line. I want you to ignore the other two that are above it. The one above it's telling, hey, React, go render something as an interface. Doesn't this look like a tag where hello message is? Like a p tag or an li or a div? Yeah. So we just taught the browser essentially a new tag that didn't exist before, right? We've known so far we've got navs and sections and LIs and ULs and Ps, but we've never before had a hello message. But now we do, right? Just like yesterday where we taught JavaScript about the fact that there's a thing called a deck of cards, we're now teaching it that there's a new kind of DOM tag that we can use called a hello message. And so far in our use of tags, we've done things like apply classes and IDs. Well, here's a secret. Those things are just considered properties. We would say the class property of this tag is the class is hidden. But as long as we're defining new HTML tags, let's just make up our own properties. So we're saying, hey, this hello message, it has a property called name, and the value of that name is Taylor. We're saying, hey, just like we had, like p tag has a class, we're saying our hello message needs some stuff. What it needs is to know the name of something, and that name of something is Taylor. It's kind of like how we define a function in arguments, very similar. Right? We're passing information to this new tag we just created so that it can use it later. How does it use it later? Right up here. So this braces here without the $sign is just like our string interpolation, except it's React interpolation. So in React, when we want to interpolate something into the HTML we're generating, we do just like we do in plain JavaScript, but we just don't do the $sign. So that says, this should say hello, this dot. We've been using that in classes, right? I mean, my class's props is short for properties. And then name is this name down here. If we change what this is, did you see that happen? Did I have to write code to erase that div and set its text content and all that? Nope. If I change the properties of that tag, React automatically repaints the user interface. Boy, is that cool. Right? I taught it what a hello message is. A hello message is going to render a div that should say hello and whatever property name I gave it. Mm-hmm. Let's put a favorite number down here. Wow. Right? Baller. Right? No more document, query selector, create element, append child, all of that BS.
The hello message that's down below,
Mm-hmm.
is that how it knows whenever you say this to select that?
Yeah. So when I say hello
It's the same
message,
class up top.
yeah. When I say hello message, what's really happening is React is creating a hello message element. This, if we were to go look in the React tools, it would say this part of the page right here, it's not a p tag or a div. It is a hello message. And then inside the hello message, we mean whatever hello message we put on the page. So here's the secret. If I put 2 hello messages on the page, one that says name is Jason and favorite number is 100, it would be 2 different messages. It would say hello Gavin, your favorite number is 42, and the other hello message would put on the page, hello Jason, your favorite number is 100. Because this .props name for this hello message tag would be Gavin and 42, but the other hello message would have its own properties being Jason and 100. Cool. Any questions on this? Right. Sneak preview, don't necessarily like, I just want you to appreciate it, not necessarily like fully understand it just yet.
So just so I'm clear, when you create a class of hello message, that is creating an entirely new HTML element, similar to a p tag or an h1, and then down there, you basically, for lack of a better word, you call it.
Mm-hmm.
Yes.
Yes, I'm asking for it to be on the page.
Okay.
I'm putting one of those on the page.
And then you, okay.
Then I can customize it by giving it properties just like we do any other tag. Yeah.
So on the second property, it's an integer, but you use quotes, double quotes.
Yeah. If it wasn't double quotes, I'd have to put these braces around it. So the rule for a property is it has to be a string, right? Or it has to be an object. So if I have something that's not a string, I have to put the interpolation braces around it to kind of turn it into a string.
Okay, and how would you add another div to that? I tried copy pasting the div, but just below it I got an error.
Yeah, so remember I said the rule is it has to return one parent element. So I could put a p tag inside of here, but there always has to be one parent.
Okay.
Yeah. So I could put an emphasis tag right here. And notice that like when I have badly formed HTML, what do I get an error. So if you have not been very picky with having nicely formatted HTML, React is going to start to get you to make nicely formatted. Because if you're literally missing one closing tag, you just get these errors. So, right, that's why I've been working with you to like be picky about your formatting and your closing tags, and I kind of giving you some of those warnings. Questions?
So you're also creating your own properties live.
Yes.
Wow.
Yep. Now, normally when you're coding, it's not going to be like this. We're going to see in a second, so this is going to be in a text file, right? And then we're going to see how we use it. Yeah, So what's happening here is this web page is like reloading this for us automatically.
Whenever we use React, it's 100% like DOM.
Yeah, we're gonna be working with this in the DOM. Yeah, and we're gonna see what it's like to create a React thing in a minute. So, right, this is a simple component where information comes in with properties. What if we wanted to track information ourselves? So here's another component. This one's a timer. A timer extends React component. Right? So timer is going to be a kind of component. It's going to be a new tag called timer. But what's the very first thing that it has as a function? It has a constructor. Right? This is saying that when a timer is created, we need to do something at initialization time. Right? So what we need to track for our timer is the sense of state. We're going to keep our own data around. So in React, any information that we keep around inside of a component is tracked inside of a special variable called state. So because we're going to have something that exists at the very beginning, we have a constructor. So we're saying, hey, every time you build a timer, let's build this state, and that state is going to be an object, and that object's seconds is going to be 0. So we create a new timer, we say seconds is 0. Right?
What if it were 2?
What's that?
Would it count 2s?
Say that again.
If your state of seconds was 2 instead of 0.
It would start at 2. Every timer would start at 2. Right? So
Not
here's...
Not count at 2.
Yeah, it would start at 2. We're going to see how it's counting in a second. So here's our render method. It's going to return a div. Seconds is this.state. state.seconds. So properties in React are things that come in that we can't change. In this hello message, I cannot change what name is, and I cannot change what favorite number is. They come into me, but they are unchangeable. Somebody from the outside world gave those to me. I can't change them. They were given to me.
Did you just change favorite number?
I changed it in the parent. The component did not change it. The person who made one of them changed it.
Oh, so,
Right? It did not change on the inside of the class. It changed in the outside of the class. Properties come to us from the outside world, but I cannot change them inside.
So you'd have to declare another property if you want to do JSON 100.
Yes, I would declare another hello message, a whole nother hello message.
so you can create your own, but also this is really good for pulling data from elsewhere. Like,
Kind of. We'll see. Put a pin in that. So in this case, I want this counter to automatically count up. Right? See the seconds there that are ticking away? So if I'm going to change something about myself, right, this component is going to change itself in some way. It's going to update itself. We're using state. This is probably still this whole idea of properties and state. We're going to go over it again, and again, and again, and again for the next 4 weeks because it's the one thing that every class that runs into React has a challenge with. The idea of the difference between properties and states. It may take you weeks to fully appreciate property and states. Right? At the high level, just realize that properties are things that come in that we can't change. State is something that we create ourselves and can change. So in this case, the number of seconds that we're ticking away is something that we maintain ourselves and change. So that this.state.seconds, right, as soon as we create one of these, that starts at 0. Right? And the render just says, say, seconds and whatever my current state is. But the second that this component shows up on the page and mounts itself into the page, the second that it mounts itself, some of you have used set interval already. Right? It kind of sets up a timer and says every 1,000 milliseconds, I want you to call this function. The function we're going to call is tick. And what does tick do? It says, hey state, you've now changed. Your state is now whatever your seconds were plus 1. As soon as that set state happens, React says, oh, hey, my state changed. I need to repaint myself. It re-renders itself with whatever the current state is. So notice, I didn't tell it, go repaint yourself. I just changed what that state seconds is. What would happen if I were to make this a 10? Right? I'm counting by 10. Right? What if I made this -1? Right? I'm counting down. Right? Plus 3. 3, 6, 9. As soon as state changes, React will automatically repaint my interface.
The level or hierarchy, does that matter? Like if you put tick above?
No, just like regular classes, the order of the functions inside of a class don't matter. But we tend to, what you'll see in a lot of places, is you will tend to see the constructor being first and render being last. Because what you're going to find now is every one of our classes is going to live in its own file. So it's super helpful that if the first thing you care about is when it's created as a constructor, that's at the top. And what does it generate, render, goes at the bottom. And all of the other stuff goes in the middle. Like the sandwich is constructor at top, render at bottom, everything else kind of floats in the middle. Right? So we've seen that React components can paint themselves. They know how to paint themselves. And if we change some data internally with state, right, everything updates. That's pretty cool. I want to do a demo for you now of rewriting the Star Wars API in React. Right? Don't worry if you're not following it and understanding it or how did I do it. Right? Today is just like a sneak preview. Right? It's like a movie trailer for React. I just want to show you how neat it is, and so you can see the difference between what with what an app looks like without it, and what an app is going to look like with it. Right? That's all I want you to do, is have an appreciation for what this looks and feels like. So let's quickly just take a look one more time at our Star Wars API app. Right, we've got a fetch that can fetch a page. We've got some code here that can render by creating a bunch of LIs for our characters, right? And a button handler next page that increments the page and repaints everything, right? Let's keep that in mind. I might actually keep that. Might need to actually keep that Star Wars page open. So let's go and make a directory for day 4. And now, for the first time, we're going to use something other than app. There's another tool that we'll install on Tuesday, or I'll show you how to install on your own if you want to take on doing a React version of this weekend's homework. It's called Create React App. It's kind of the inspiration for app. So with Create React App, we will just give it the name of the app, and it creates a new React-based application, which is going to look a lot like an app, but a little different. So let me close these. So it's gonna create an app. Now it's installing all of those dependencies, and this may take a while. What you'll notice here in a second, it's kind of in the text here. You notice like the HR process looks a little different. This is because Create React App uses Yarn instead of NPM. So probably for point out, all the things that we did with NPM, like NPM start, we're going to use Yarn. We're going to switch at this point from NPM to Yarn. It's pretty much the same thing. It just has a fancier user interface while we're installing things. And for a long while, it was much faster than NPM. Yep. So here we are. And it gives us some little guides at the bottom as to the different things that you can do. So just like a app, we need to go into that directory and code dot. That's all the same. Here's our code. And then we're going to yarn start instead of npm start. Okay. And it's going to start our app. Hopefully. Let's make this full screen. Put this over here. Hey, here's our default hello world for React. Much fancier, right? Wow, it's so cool. Let's go take a look at the parts of a React app. So we still have our source directory. We have our public directory. You'll notice now that our public directory has an index.js, index.html. You're going to find that we almost never touch it. All of the HTML we create now is all going to get created via JavaScript. So the index.html only exists to load all of the JavaScript that we're going to create with our app. So we don't play very much in the public directory except when we need to add images or some of those things.
It's going to be like that from here on out?
Yep. Yep. As long as we're working in React, that's how we're going to start coding. So we'll go over this again on Tuesday, if that's kind of blowing your mind.
Essentially, if somebody turns off their JavaScript on the browser, nothing.
Yep. If we turn the JavaScript off here, then there is nothing in here. And I forget where we go now to turn that off. Settings. There's a way to turn it off for just the one page. There's a way to turn it off just for one page, though.
You click on the I, the logo.
Where?
The, in the address bar,
Yeah.
here's the I.
Search here. Cool. Thank you. All right. So you reload the page, right, and you need JavaScript to run this app. So since React is all JavaScript, right, everything that we render, we're going to be rendering inside of JavaScript.
So most workplaces, well, a lot of workplaces still do use HTML files.
If you're building a React application, you're probably going to be building all of your HTML inside of React.
But if you go to a workplace and they don't use React, you can bet that will probably be.
Not necessarily. If they're using Ember, it's done differently. If they're using Knockout, it's done differently. So every framework's going to have its own set of rules. Almost every JavaScript-based UI framework is going to have you write a lot of the stuff in JavaScript, maybe not in plain HTML. Or it'll be in their flavor of enhanced HTML. If you are writing marketing pages, you're just writing plain HTML. If you're making web applications, right? If you're making Facebook, right? Facebook is not just an HTML page, it's an application. Guess what Facebook UI is written in? React. Who created React? Instagram. And Facebook got it when they bought Instagram. And it was an internal tool that Instagram created to create their web interface, their application. And when Facebook bought it, I'm like, wow, this is really cool. They open sourced it to the world. It used to be an internal tool at Instagram, right? When they got Instagram for like $2 billion, like part of what they got was React from them, plus all their developers, plus all their users, right? Plus all their ad money or whatever.
When did it become open source? What year?
A couple years ago, three years ago, something. Pretty soon after they acquired, I think, but I don't remember. So now it's an open source thing, but I'll show you in a second when we show the React tools that all of Facebook's user interface is written in React. It's just a huge React application.
So does that mean that Mark Zuckerberg is sending all of our React that we write?
Yes. Yes. Every component you write, he gets a copy of all of your code. So let's go look at the component that's building this. It's telling us, hey, source app.js is this component. So here's our component. So your question earlier, Frank, is I want to return more than one thing. Notice that in the return of this component, we're only returning one div. But inside of that is a header, which has an image and a p tag and an a and a header and a div, right? The rule is you can return one element, but that element can have a lot of stuff inside. Right? So every return just returns one parent element. That can have multiple stuff. All that stuff. Right? And the page should reload, right? And we kind of get nothing, right? We just get a div, hello, world. If this was, right, nothing. Let's take our interface from, where did it go? Our interface from this app and put it inside. So this is what we want inside of our React application. It has to go inside of this div. Right? Since there has to be one parent, here's our Star Wars. Let's work on the page number first, because these will give you the clearest example of what you want. So the page number here is a state we're going to maintain. Right? We're going to say we're starting on page 1, and we can move to page 2, page 3, page 4. So if we are maintaining our own state, this boilerplate will exist in every component that ends up having state will have this constructor that takes in properties and calls super. Super calls the components constructor and passes those properties up. Just know that this boilerplate goes at the beginning of every constructor in React. So let's make a new state, and let's say the page number is going to be 1. So this dot state is saying, hey, app component, your state is an object. Almost always the state's going to be an object, so we're eventually going to want to store more than one thing by name. Objects are super helpful for, and its state, this page is 1. So instead of saying page 1 here, let's ask this component state for the page. Oh, and I forgot the closing. See how picky it is? Like, if I make a mistake and this is an H4, right? If I leave off this closing tag, right? So this is why I've been harping on indentation and opening and closing tags, because JSX won't let you get away with SWAPI HTML. This writing HTML inside of our JavaScript has to be well balanced and correct.
What is JSX?
We'll talk about it on Tuesday. I'm giving the it's the word that they use in the movie trailer. They don't explain why that character is there until you actually watch the movie.
Before you said like the number 1 there, page 1, did you say it had to be an object?
Well, that's when you're passing it as a property, right? So I'm string interpolating it here. So this is actually turning that number into a string and then putting that string inside of this text.
Does Courier auto indent HTML JavaScript?
It will automatically indent your JSX, yes. Yes.
Does React render it always in the body?
No. So eventually what we're going to learn is you can put components inside part of a page somewhere else. Right now, the app component, the way it's written, is the body. But one of the nice things about React is you don't have to turn your entire application over to it. So what if you wanted that little counter on your page? Like, if you've been on my site for X seconds, you could just make that part of the page React, and the rest is plain HTML. But as soon as you crack open the React box, and you say this part of my page is React, then the things inside of that are all going to be HTML inside your JavaScript. But React can sit inside of a much bigger plain HTML page very nicely. That's not true of some other JavaScript libraries and frameworks, where you have to turn your entire site over. But the second you kind of enter the React world, everything from that point down will be React-style JavaScript in the middle of your HTML. Right, so the behavior that we had on the button is when you're clicking it, we would like you to change the page number. So let's write the function first, and then see how we use it. So we call this next page. Now I'm going to go back to writing arrow functions. From this point forward, we're going to write our functions in here as arrow functions, the ones that we write. You can also write your render function this way. What you're going to find is when React creates files for you, it's going to do it the old style way. For the functions you create, I would like you to create them as arrow functions, even if the render function that the React tool spits out is not. And then sometime next week I'll explain why. So what we want to do here is we want to increment the page number. I wish we could say this dot page equals this dot page plus 1, but I'm sorry, this dot state dot page. But we can't. The reason why we can't is there's no way for React to find out that we changed this state variable. So in React, like, wish we could do this, but we have to do this. We have to call a special function called setState. And what setState takes is a new object to modify the current state. Any object properties we put in here will update the state. So what do we want to change? We want to change the page. We want to make it whatever the current states page is plus 1. Right? Nothing's happening yet. But if I say, hey, button, on click is this dot next page, that's kind of like add event listener click, comma, page. I'm telling that when this button is clicked, I want to call my next page. Just changing this variable, what's happening is this whole thing is getting repainted. React is going in and saying inner HTML out, new HTML in. And it's even smarter than that. It can look at all of this HTML and know that only the H3 tag needs to be updated. It will only target the part of the page that needs to be updated. It's that smart.
Is it really changing the page, or is it just changing the number?
Yeah. So if we come into console and you bring up this, so in the console, if you hit escape, this little console pops up, and under rendering, you can turn on this thing called paint flashing. And you'll notice that like as you reload a page, so you see that green flash, it's kind of sometimes hard to see on the, yeah. That's all that's updating. Right now, the only things that are flashing green is what is changing on the page. So if we were doing this old style, let's turn on paint flashing here. Let's say it was rendering paint flashing. Look at that, right? The whole dang page updates every time I hit next, right? See how everything is changing on the page? That's because I'm deleting all of that content and recreating it, deleting it and recreating it. React is smarter than that.
So it's creating a page every time you hit next. There's really not a page there.
There is a page here. This HTML is staying here. All that's changing on the page is this. The only thing that's...
Like the old way we were doing it. There really isn't a page 2 until you hit the next button, or is it really there?
The only thing that's on this page so far is what you see. All that's happening is this HTML is re-rendering, and is re-rendering with whatever my page number is. Right? I haven't done anything with the API yet, or fetching, or classes, or none of that's happened yet. All I wanted to show you is that the way you update a page is by changing your state and your UI refreshes. But the only part of the UI that refreshes is the part that's actually being redrawn. Right? The only thing that's changing is this.
What was Facebook using before React? I don't really care about it.
I don't know. Probably their own thing.
Their own version of it.
Yeah, but their own set of tools, whatever it was they were doing, and I don't know what it was.
Right, huge plans, huge
Could be.
applications.
Yeah, or they were using some other internal tool that they had never released. Right? Many companies have their own internal libraries that they don't release to the world for making their code simpler.
Okay.
And that may have been they just never made it open source. And then when they got React, they're like, oh, this is cool. Like, let's open source it so the whole world improves it.
So a library is like, it's like they use vanilla JavaScript, vanilla whatever, and they make their own classes that make things happen easier.
Yes. Yeah. It's like using somebody else's code that they made and are giving to you and saying, here you go, Gavin. This code makes things simpler. Please use this. As an example, Dylan wanted to do some parsing of dates in his weather app, and parsing dates is really hard. So there's a library called Moment.js. That's another library that somebody wrote that can do all kinds of fancy date things. Take today's date and add 7 days to it, right? And then tell me when the next Thanksgiving is after that. That kind of crazy stuff, right? You don't want to write that code yourself. You're lucky that somebody else wrote a library of code. You can just pull that library into your application and use it. And that's essentially what React is here.
How much does React slow down a page?
Almost none. Almost none. And it's probably going to be faster than whatever hand-rolled thing you did, right? Because they've got thousands of geniuses working on React to make it fast.
Okay. So they're not loading like
Yeah. React, so people are like, React, it's all this code, it's going to make it slow. I can guarantee you it's going to be faster than anything you're going to write based on your skills in the next 7 to 10 years.
Okay.
Yeah.
Fair enough.
Right. They are working on making React as fast as humanly possible. And it's going to be faster than doing this kind of BS, right? Where we're like removing all the things from the DOM and then like shoving them back in, right? Since it runs Facebook.com, they want that to be fast. So React is going to be super fast. Let me show you that real quick. So here's our app. You'll notice that I have another tab in my browser that you all don't have, which is React. React lets me look at my page from a React perspective. So now I'm browsing elements, but I don't have the plain HTML. I have the React component. And down here, it's telling me that my app has props and state. And I can look at the state change. I can even come in here and change the state. What? Right? This is me, like in the developer tools, calling setState and making that page whatever I want. That's awesome. Hopefully there's nothing weird on my Facebook page right now.
Is there security issues with it?
Nope. Is there security issues with your JavaScript? It's just JavaScript. It's just JavaScript. So whatever security issues you would put in your own JavaScript would be in whatever you write in React, right? React doesn't deal with APIs or data or anything. All it deals with is taking data and rendering it on the page. Whatever data you put in and how you tell it to render is what you end up on the page. Look at this from a React app. This element here, let's go. Try to find an example. Trying to find an example. Let's make it bigger. So if you look at, here we go. Maybe not. What do I normally do? I normally use the chat as an example. Yeah, here we go. So here's a React app component. Look how many levels deep it is. Right. Here's a chat sidebar user root container that has a chat sidebar user root profile that has all these properties. Right. So this page that you think is like some web page is really just a big React application, using all the same things that you're about to learn in React. Right? It's super complicated, but at the end, it is just a React application. That's all that the Facebook user interface is, one giant React application. Let's see if we can update this now to render our data. So I'm going to come over here and steal my character class. We're going to want that. Let's put that in here. And let's grab this fetch. And then let's do this. Let's make a function here called get characters from the API. Oops. Get characters from the API, and we're going to grab this code right here. So rather than render the data, right? What I want to do is I want to do this work right here. I want to take that raw data and turn it into a list of characters, because the other thing that my state is going to have are my characters. and they're going to be an empty array. Right? When we start out, we're on page 1, and we don't know about any of the characters yet. Why is it even caring? And this is this.state.page. And we have a get characters from API. Now, when we get the characters from the API, I don't have to do anything with them other than call this.setState and say my state's characters are the characters I just created. Every time we update the API, rather than deal with any kind of DOM or updating things, I just say, hey, the characters you just got back from the API, throw them in your state. Just like we said, page equals page plus 1, right? So if that's true, right, maybe down here, instead of having a blank UL, what if I could go through my characters and throw them right in the page? This is where map becomes so important. It's about to happen. Let's put some JavaScript code in here. And let's go look at what we put in here. We created an LI, and we put the character's description in it. Let's go through our this.state.characters, and let's map each character into, hold on to your propeller heads. We're going to turn that into an LI whose content is character description. Right here in the middle of the page, I'm using map to turn my characters that are from my state into LIs that render the character description. Right? No query selector, find, append child. I'm saying that inside of this UL, please run this little bit of JavaScript and take my this.state.characters array, right, the character objects, and turn them into LIs. If I have 10 elements in my character array, I get 10 LIs. If I have 100 in my character array, I get 100 LIs. This is why the idea of map and filter are so important, because this is kind of what React is based on. So now, when our app starts, let's just call this.getCharacters from API. Oops. Oh, not, and its description called. Okay. What happens now when I go to the next page? Aha. When I call the next page, right, I also have to call get this.getCharacters from API. There we go. That was weird. Right. So as soon as I also, oh, I know what's going on. So did you see that, like when I clicked next, the page changed and then like it took a second? Right, it's because the set state doesn't happen right away. When you call set state, just like other things, it's asynchronous, like the fetch. The state changes at some point, and then when the state is changed, it just updates. So these two things happen asynchronously, and the way you fix that is you create a callback for the state. Oop, I want the second one. To say when you're done updating the state.
How are you searching for that?
Command F for find. So set state can take two functions. So let's make this a function that does this, and then let's take a second function that does this. This is a bit of a tricky thing. Don't worry about this. I'm just trying to get this to page 1, page 2. Right? Now all I have to do every time I update the page is increment the page number and ask the characters to be gotten from the API. And when I get the characters from the API, all I'm doing is saying, hey, state, remember you have some new characters. So in React, what we tend to do is describe the user interface in one place. Right? This just describes the user interface. Hey, I want a div with an H1 and H2 and a page here, but don't put a hard-coded page number. Put the page you're getting from the state in there. And then I want my UL where my characters are going to go. But I'm going to dynamically generate them based on turning my array of characters into an array of LIs. Right? That's what map does. It takes an array of one thing and turns it into an array of another thing. Every character goes in, an LI pops out. A character goes in, and an LI pops out. Those LIs end up existing inside of here.
So in the background, that's still an array?
This is an array of LIs. It's as if we had come in here and written LI, right? Jar Binks has been in 2 films. It's literally writing that for us.
I was just wondering if they converted it from like an array to an LI, but it's
Yeah.
still an array, but it just makes LIs.
It's an array of LIs. Yeah, this is an array of characters, and it turns it into an array of LIs that go into the page. Did you have a question?
Yeah. So there's a delay from the API rendering.
Mm-hmm.
How do you do like loading?
Yeah. So we could have another state inside of here. That's a really good question. Let's make another state inside of here called loading. And let's make this false. So down here in our render, what we can say is, if we are loading, let's return a div that says loading. This.state.loading. So now we have a condition. If we're loading, our entire user interface will just say loading, otherwise we'll have the user interface. So if we were to go into the inspector and change that state, let's come into here and change the state loading to true. If we change this loading away, so as I'm toggling that loading, right, I get this different effect. So let's use that to our advantage. Let's reload this page. So now, as the characters are calling, before we fetch, we say this.setState loading is true. And when we actually get the characters, let's say loading is false. It's that easy. I'm just managing state. So if I can manage the state to reflect what's going on in my application and tell my render to happen the way I want, it just does what I ask it to do.
Can you show me where character.description is above?
Yeah,
So that's still back in our old class character. That's still the same thing. That's still our character class.
where is description? Okay.
Right? This is the same code that I brought over from the non-React version. Right? This is just a class that helps me manage those characters. That's still the same. Right? So React is just maintaining data and keeping track of data. This is why, like, we had you work on Blackjack. Right? This is why we had you work on classes for Weather API. We're building towards the idea that our classes and our data and our functions are what are going to paint our user interface. Right? And we're getting away from having to manipulate the DOM directly, we get this nice, hey, just describe how the page works. Right? All I've taught about HTML is I want a div with a couple of H2s and an H3, but put the page number where I want the page number and put my character LIs where my character LIs go. That's awesome, right? Nice and simple. I can look at this and go, oh, I know what that page is going to look like. It's going to have Star Wars characters, a page number, and then a whole bunch of LIs for some character descriptions. Right? That's what React gave us, right? Ooh, simplified our lives. But it's now added this new context of having to maintain state and properties. Right? So that's the giveth and taketh away. Right? It's given us that we have a much simpler way of managing our application state. And trust me, as our applications get bigger and bigger, this is going to be a real help for us. But what it's now said is you've got to do things in a very specific way. You have to have a component. You have to deal with state. You have to deal with a render function. These are the rules that if you live within, what React will give you is this nice fancy ability to just modify data. Right, if I just modify the state, let's look at the state here. I need more space. Let's move this all the way out and let's put this on the side. Right. If I look at my app and I find my state, it's an array of 10 characters. Did you see that? I'm just manipulating data. I'm just changing data and my interface is updating. Can I delete one of these? I don't think so.
It'll go away when you reload the page.
Yes, right? Because what will happen is the data will change again. I'm changing the data and the page is updating on its own. Right? When we work in React, now what we're just going to be worrying about is manipulating data, loading data from places and manipulating it. Right? Fetch, map, filter, and writing functions. Right? So I like the code katas in the morning are our good practices. Right? How do I take an array of numbers and turn them into squares? How do I take an array of stuff that comes back from the API, like character objects, and turn them into the list items that I want? Right? The rest was just styling. Let's steal the styling from the rest of the page. Let's grab that. And in here, index CSS is our page. Here's our thing, and then we need, inside of here, we need our images. I'll get the images later. All right? So this kind of now looks like our other app. That loading is really annoying. Let's not have that in here for now. Let's comment that out. Oh, you know what we can do? Let's do this instead. Right inside of here, let's use a ternary. This.state.loading. If this is loading, then what I want is the word loading ... Otherwise, what I want here is the word characters. That's better. Oh, and then close the brace. Right? A little bit of JavaScript right in there, and now, all right, that's a little better. Right? I don't care if you understand even like 5% of this. What I want to convey today is this is the direction we're going when we're in Unit 2. Unit 2 is about building up all of these skills. We're not going to build these skills on the first day. Right? These are the skills we're going to be building over the course of Unit 2, front-end frameworks. We're going to move towards this style of coding. What Cohort 11 is working on is they're building their React front-ends that are using fetch to go get data, or they're not getting it from Star Wars API or from Open Weather Map. They're getting it from the applications they're building in Unit 3. So in Unit 2, we move from raw JavaScript and low-level query selector create elements to a higher level of programming with classes and components in React, but we're still using somebody else's backend, right? Star Wars API, Open Weather Map, something else. In Unit 3, we layer in you creating your own backend to supply data to a front end. And then your capstone is integrating all of those together. That's what Cohort 12 is working on. Sorry, 11 is working on right now. Yeah. So today's just a preview. I just want to show you like the power and style of a React application. I don't care if you, like, don't freak out if you're not getting this. If you can appreciate it and kind of see the direction it's going in, right, and the change in style, that's mostly what I want you to feel from today's lecture. Like, okay, cool. I'm not writing all this low-level code to do things. I'm describing my page, and I'm changing data. If you don't understand how that actually works, or how you change the data, or why I wrote something in some particular place, that's not what today's about. Right? Today's like movie preview day. Next week, we start playing the movie. Right? We get to see how it really works. Right? But this style of programming, when our applications get bigger and we have multiple pages of our application and it's doing multiple things, it's pulling from different sources, the ability to group together to encapsulate this idea of this component is going to be the one that's going to count the number of seconds on the page versus this component is the one that shows me all of my Star Wars characters. Being able to separate that code will start to really help build bigger things faster. Right? So hopefully you start to see how some of the things we've been working on the last couple of weeks in JavaScript start to come together. Right? Arrays, fetch, classes, map, all these things are going to be the tools that we're going to continue to practice in Unit 2, but just in the context of now doing it inside of React applications. Right? So your homework for this weekend, right? And you've got extra time because you've got an extra day. So you'll hear Cohort 11 be like, oh, they got an extra day? Your homework for tonight will be, dun-da-da-da. Nope. Yep. You're going to implement tic-tac-toe. You're going to make a tic-tac-toe game, a two-player tic-tac-toe game. Right? So what we're working on is planning and designing some ideas. Right? What is your tic-tac-toe game going to look like? What happens in a tic-tac-toe game? Right? There's an idea of turns. Somebody goes first, somebody goes second. There's a win, lose, and tie. So here are the requirements. The game should be played on the same computer. So it's a two-player game, but both players play on the same computer. There should be a tic-tac-toe board visible on the screen. Should alternate between X's and O's. If you click on a square, it plays X or O, respective of whose turn it is. So if Frank and I were playing, I would walk up to the computer and I would click on the center square, and I would get an X or an O, whoever's first. And then Frank's turn to take over the mouse, and he would click on another square and get an O. We'd go back and forth until the game was over. 3 in a row, you've won, and the game should be over. Or if it ends up in a tie, maybe see if you can have it say tie. Your design should be so detailed, your user interface sketch and your list of steps should be so detailed, you could give them to another team and they could implement it without coming to ask you questions. That's how detailed your plan should be. So a lot of planning first. Explorer mode. You're going to do this in pairs. This is a homework done in pairs. 2 people are together going to create the same app. So you're going to turn in a repository that is a shared repository. So you can both work on one repository and then the other person can fork that repository, or you can come see me this afternoon and I will show you how to both collaboratively share one repository. So what you're going to turn in is a full design of how you're going to approach this problem, right? So this should include some kind of mock-up of what the application is going to look like. So there's going to be a scan of you can go to the whiteboard and draw it and then take a photo of it, but you're going to turn in that photo to me as part of your design, right? And a list of all the things you're listening for, right? So maybe some clicks, and then the pseudocode describing your program. That's the detailed English steps, right? Probably do all of this first. So if I were giving pairs of you tips, I would say you're going to work on all of that this afternoon and during lab time you have tomorrow, and try and show that to me before the weekend starts. So I can be like, cool, I think that's a good way of approaching this, right? And then you're going to create your tic-tac-toe game. So your adventure mode is plan the implementation of a tic-tac-toe. Oh, sorry, explorer mode is create the tic-tac-toe game. Adventure mode is see if you can make it play against a computer. So it's a one-person game. Just one person plays it, right? And have some fun with CSS and colors and animations and sounds and whatever to make the game more fun, right? And then in epic mode, make it play versus the computer with a very specific strategy. So like go see if you can learn how to make a tic-tac-toe AI essentially, right? It is possible to make a perfect tic-tac-toe playing computer algorithm that the computer would never lose. See about that. But at its base mode, explorer mode, design out the entire thing first, then go implement. So figure out today what pairs you're going to work in, right? So I'll pair up into teams of 2, and then let me know which 2s are working together on tic-tac-toe. Right? And this is due on Tuesday. So you've got today, Friday, Saturday, Sunday, and Monday. A good amount of time to work on it. I would take today and sometime tomorrow to work on this part, your design, on how you're going to approach the problem, and really see if you can list out in long detail how the tic-tac-toe flow is going to go. Right? The most challenging thing is probably going to be the deciding who won and who tied. Really dig into that. Right? If you don't start coding HTML or CSS until late on Friday or even on Saturday, cool. That might be about the right amount of time. If you come to me tomorrow and you've got your plan and I think your plan is good, start working on HTML and CSS and JS. Right? But really dig in. This is a really great practice to really focus on that planning aspect. Questions?
My question is on picking partners.
Mm-hmm.
Some of us are not as good as others.
You should pick a person whose schedule works with yours. So like talk about what your availability is on Saturday, Sunday, and Monday, right? I think any 2 pairs of y'all will be able to tackle this problem. There's not 2 people in this class that if they were to pair up, I don't think could capably handle this tic-tac-toe game if you spend this requisite amount of time working on this part. You know, I'm not worried about any pairs in here. Right? Some may finish first, some may finish later. It's not a race. I think if any 2 pairs really digs in here and spends the time out on a piece of paper, on a whiteboard about like, how do I know if I have a tic-tac-toe board that looks like this? But that's not a winning game. Right? How do I know that is? Or what this is? That's going to be the trickiest part of this app. Everything else in here, kind of already done. It's kind of like Rochambeau, but more difficult. Right? If you think back to how you did Rochambeau, isn't it kind of like that? Like player 1 goes, player 2 goes. Now it's player 1 goes, player 2 goes, player 1 goes again, player 2 goes again, player 1 goes again, player 2 goes again. Right? In Rochambeau, we just said if I pick paper and you pick rock, I win. Now you've got to deal with there being 9 squares on the board. So if you dig into this, and literally you're probably going to have to play dozens of games of tic-tac-toe and think about what's happening at every stage of that. And how would you describe how to find the winner in a tic-tac-toe game? How would you represent the information of a tic-tac-toe board? That's the key to doing this assignment. Right? The key to this assignment is more about this than it is the JavaScript. The JavaScript, I guarantee you, will be quote unquote easy if you really dig in there. So figure out who works well together, figure out whose schedules work well together, because you'll have to like coordinate on the Saturday, Sunday, and Monday when you're not, like it's not 9 to 5, Monday through Friday, right? So think about like, well, like on Sunday I can't, and these are the times that I have available to work together on stuff, and figure out like both, like which people work together well, and then whose calendars work well together, especially because it's a longer weekend, and it's also got a holiday in it, right? And then come let me know, probably by the end of the day, which groups are pairing up. You can send me a Slack message and say, hey, I'm pairing up with this person, I'm pairing up with that person, just so I know who the pairs are. Cool? So okay, kind of first group assignment. So organically amongst yourselves, figure out how you want to group up.
You got in your car this weekend?
So you don't actually have to physically be in the same place all the time to work together. You can always work together over Slack. So if that's going to be the case, or you think there's going to be a challenge with coordination, come talk to me and I'll show you some hints on how to do it.
When it was Saturday night,